with that, where we discussed all the aspects of high rise, and we were just about to start with the envelope design of how a high rise and the envelope has a very close connection to sustainability, and not just about sustainability, but also about the basic comfort levels that a person feels when you are, say, about 70 floors high up in the sky, and you are facing the blast of the sun and the wind that comes onto the facade. So the whole skin, like how our skin kind of changes, the sweating in the summer, so that you get evaporative cooling, and dryness in the winter, so that you don't feel very cool. Imagine sweating in winter and you get a cool chill air on you, it will be freezing. So the skin adopts, right, according to the season. Similarly, the envelope system, for a very long time we followed the passive system, which was the best. In its inherently, it was one of the best. The reason being, it considers everything, right? It considered the way the building is made. It considered the material, the kind of systems that was adopted, the thermal mass, and everything that goes to make a passive building a passive building. And essentially, now, one second, guys. Yeah, hi, Vikram. Yeah, you guys, can you hear me?
Yes.
Okay.
Yeah.
Yeah.
So we finished with all that, right? Now we will be coming to the envelope design, and what it is and how it is. We all know that it's a physical interface between indoor and outdoor. Okay, just like our skin is to the indoor and outdoor, and it is responsible for much of the energy balance, which I just talked about. Okay, so envelope is what we are going to talk today, and how it can be more sustainable, and how it can create these energy balances within a building. Okay, and it depends definitely on a type of construction, material used. Okay, the construction techniques used, lots of other things. Okay, basically, so for example, if I have to give you an example. Okay, say you are using extensive use of glass. Okay, very common in office buildings that you will see even in Mumbai. But say you are using this, say in Canada. Okay, which will be fine, because you need sun to come in. You require the heat to come in, so that the heating loads would be reduced. But you take the same material and start using it in, say, India, or say in a Mediterranean region where the summers could be harsh. So the climate also needs to be studied before you start introducing your I mean, sorry, your what do you say, your materials. Okay, so thermal comfort definitely needs a big study of climate, and then how would you then go about. Okay, supplying natural light is another big task that every facade will have to work on. So the balance between daylight and heat is an ongoing. tussle. I would not say the word research. It's like, should I give more glass? But if I give more glass, there will be more heat. But I need more daylight. Okay, so always this kind of balance is a worrisome factor for most of the architect. How do you then control that? And that's where, especially in a high-rise building, where because there is no obstructing kind of a thing right in front of them, you can see that the sun blasts on and you don't know what to do. So that's where the intelligence, the smart material, the kind of responsive facade, the biomimicry facades, and we'll discuss each one of them in detail with hopefully some case studies that I have been able to find on each one of them, more or less. Okay. So what does actually the facade does? Okay, it definitely climatic conditions को adopt करता है, and accordingly it tries to see that the energy demands are reduced. So what are the typical characteristics of a building facade for a small, okay, or a big building? Doesn't matter whether it's a high rise or a building, but basically it needs to do all this. It allows daylight, okay, preventing unwanted solar heat. यानी कि you don't want the heat to come in, but depends, as I said, on climate. The heat could be a problematic in America in during this time, okay? Like this time, the summer is going on and the temperatures are 33, 35 there. For Americans, that is too much. They can't just, because the most 8 months of their life of the year they spent in some degrees of 10 to 15 or 18, and now suddenly the temperature soars to 35. For them it's highly uncomfortable. So the building has to see to it that solar heat has to be managed, whether good, bad, it still has to be managed. Storing heat within the mass of the wall, if possible, but again, climatic concerns, you'll have to figure out where you are doing what and what kind of mass you will be using where. Preventing heat transfer through improved insulation, which we have done in your second year when Kimaya took you through all this, R values and U values and all that. Or allowing natural ventilation to cool the building interior. Again, first year, second year, we learned all the techniques of how do you manage it. And Al Bahar, the tower in Abu Dhabi, believe me guys, 70% of it uses natural ventilation, though it is like 70 floor high, and amazingly beautifully done. And we'll see, I have a case study where I can show you exactly what it is. And these are the types of the building facades we'll mainly deal with: opaque and transparent. Opaque facades are, I wouldn't use the word absolutely opaque, but of course there are seeable component within a facade where you actually have a window and a view. It's also important to connect to nature or outside, right? It can't be like just a wall and you're sitting in that. It will become another basement, right? We don't want that. So you would, opaque facades are always a part of your transparent facade. So basically it always, it's a mix of these two when you're talking on facades, okay? So, so what is basically climate that one? So one climate will be actually demanding more heat to come in. Where my heating loads are very important, and in other climate it will be where the cooling loads are very important. So when it is a heating dominated climates where I need to, heating dominated यानी climate heat nahi, heating dominated, heating loads are dominating. Okay, I need to see that I collect maximum solar radiation. Okay, when I have to heat my building, I will see to it that I will create a kind of a trap where I can take most of the solar radiations. Okay, so passive heating is of the prime importance, heat storage, thermal mass. Okay, and then the question is, if you're going high rise and we are talking about structural stability and we are talking about seismic and wind zones or the wind loads, then thermal mass doesn't work. So then what other technique could be used? Improved insulation to reduce heat demand and the use of the daylight to reduce the lighting demand. Now, guys, by default, sustainability is a part of the envelope design. Okay, so reducing energy load, reducing lighting load, reducing HVAC load will be a part and parcel of all that I say. Now, in cooling dominated climates where cooling needs to be done very highly, that means you are in a very hot and dry kind of a region, protection from sun and the direct solar radiation becomes more important. So now if you are taking a building and just randomly placing it in different conditions and different climates, then you know the grave consequences of the same. And that is exactly what BKC is going through, right? You have these buildings which are like totally curtain walled and extremely high amount of HVAC tonnage is being used because the building gets heated up. Okay, so how and when you use the material becomes very important. And in a mixed climate, the condition is how do you then balance both, because equal heating we have, equal cooling we have. So then what will an architect do or arrive at a system where he or she can manage this? Okay. So design strategies need to consider the condition of the climate zone first thing, okay, to minimize their impacts and reduce energy consumption. That was the reason the focus on environmental was so high in first and second year, because those are your formation years of architecture, where you actually learn that on based on this, your complete architecture can be based on. And if you do not consider this, there can be grave consequences in terms of sustainability, in terms of form, function, and the beauty of the building. Yeah. So these are the some of the things that we always tussle. You know, it's a fight between shading karna hai ya artificial lighting hai. So if I shade more because I don't want sun, then I have to depend more on the artificial lighting. So this tussle is an ongoing thing, and solar gain versus overheating. So I need solar gain, but then it shouldn't be that overheating ho jaye. So then what is that balance, and how do you manage that balance? Do I have to do it manually? Do I have certain methods by which I can control the sun? Can that be done manually, or is there BMS system involved in that? All these questions, come up cropping up and especially when when the ownership of the building is like you don't know, and everybody is using it, and it's everybody's building and nobody's building. So then who takes care of all this thing? That's where BMS or the automation system comes into picture, and that's where the smart facade came as a kind of a system. And people started thinking in terms of how can we make facade itself very smart. The human intervention is not required. Okay, then view versus privacy. So some people will say I want large windows, but then other people will say array large windows hai to privacy will be hampered, somebody from the other building will be able to see in, and all these kind of questions, queries, daylight versus glare. So again, if I have good amount of daylight coming in, but साथ में glare भी आता है, so then how do you control that? So all these become a very kind of a criteria for you to design actually which system that should come into it. And there are various existing typologies that happen. हो सकता है future में few more typologies can come up, and we'll go through each one of them quite detail में. And obviously, if I have to take any one of them, say I'm taking shading versus artificial light, okay? How will I do? Conventionally, हम क्या करेंगे? Shading system लगा देंगे. कौन सी लगा देंगे? Roller shades है, which can be opened or closed. It can be Venetian blinds. It could be normal curtain that can be, again remotely controlled. Or I might have chhajjas, or I might have grills, jalis, which will allow only diffuse sunlight to come in. But then probably it will not give me any views. So there are various ways, conventionally I can do it. But when I'm talking about AF, that is adaptive facades, okay? What innovations, what different configurations and changes could be based depends on how the user demands, है ना? अभी कोई नीचे first floor वाला बोलता है I don't need the view because सामने building ही दिखने वाला है. But maybe on a 70th floor, the guy says I get a lovely city view and I would love the view up there. So then there is two different opinions, and then how would then that configuration take place? Okay, so basically, what is adaptive facade? Okay, so to address above points, two alternative approaches have been widely tested. Okay, converting your conventional daylighting systems into conventional adaptive facade, where it can change its shape and allow diffusive or maybe more sunlight to come in as per the setting. Okay, or the systems. Example, motorized Venetian blinds, as I just said, or maybe a light shell which can again fold up or open up, or using complex fenestration system, generally known as CFS, okay, and which are characterized by their ability to change the light angular direction. So they are able to shift and allow the light to come in certain ways, so they can avoid the glares, but allow the light to come in. They might not take the heat inside and reflect the heat out, but allow the light inside, something like that, And there could be prismatic films or the laser. Shit, I forgot what is LCP. Oh, I'll remember. Okay, so this is how you will basically that is basically your adaptive facade. Okay, it's basically a building shell which kind of changes its function or behavior. So you might have heard about phase change material. वो भी वही काम करता है. So they take the heat from the sun. With little heat, they change its opacity. So suddenly you will see that the gel, which is kept between the two layers of the window, which is double shelled, I mean double protected. In between, you introduce this kind of material known as a phase change material, and suddenly your privacy is well maintained. Okay, it turns opaque and it becomes, you cannot see, but at night time it turns again. So all these different and phase change, it's necessary नहीं है कि heat लेगा तो opaque ही हो सकता है. There are other materials which can turn into completely, clear. So that's basically your AF. It changes its shape, material, state, moves, it responds, it thinks, various kinds of. So yeah, I mean, there are different definitions. You can go and find out, Google karo, you will get 10 different definitions for AF. So basically, the idea is adaptability. How just as an animal or a plant adapts, okay, or a human being adapt to the environment, same thing, building has to be done. So in second year, remember we did before we started with the services. Okay, I always start with the comparing of how do you compare a building to a body, and most of the systems kind of matches. This is also one of the system where intuitively a human body adapts to a certain region, okay, over a period of time. It doesn't happen overnight, but buildings are not, I mean, we make buildings, right? So we can do that. Adaptability is basically a potential of the system to deliver multi-object comfort criteria, and the comfort criteria could be many. Okay, it could be, I don't want the sound to come in, so it could be acoustical comfort, it could be thermal comfort, sensory comfort, so many others, psychological comfort, privacy mera maintain hona chahiye, kind of a thing. So there are various kinds of comforts that can come in, and there may be some few more which I don't know, and it can come up contextually. Okay, and the best part is the physical characteristics. It doesn't take a long time. Okay, ऐसा नहीं है कि सुबह चालू हुआ तो दोपहर तक होगा. By that time the guy will be roasted there. So it happens in a very small time scale. That's very important. And then when I'm saying about how does this happen, ये एक होता क्या है? So as I said, it thinks, it responds, it moves. Okay, it's passive. What is it that make it does all this? ये क्या चीज है जो इसको ये सब allows it to do all this, right? And those are the feedbacks. The feedbacks you get are from three systems, basically three components. You have sensors on the facade, you have processors, or you have actuators. Okay, so basically when I have the feedback, definitely there will be some kind of a control now, or I would say some kind of management. Let's use the word management. I've used control here, but it could be either. Now when I'm talking about control, internal भी हो सकता है और external भी हो सकता है. So there are certain systems where the material itself take the call. They don't wait for a human being to come and do the changes, or they don't wait for the electricity to send the impulse and then it will work. No, they got the feedback and they started changing. Okay, so that's intrinsic, completely taking a call at that point without any interference or without talking to anyone. That is intrinsic. Okay, it's completely decentralized. It is not mixed with any BMS system. Okay, it's direct, it happens then and there. While in extrinsic, which is external control, that means all this feedback in the sense कि by heat बढ़ रहा है, okay, suddenly the temperature is soaring to 36 degrees, so that's a feedback. Now, the feedbacks could be coming through sensors, it could come through processors, or could anything. Once the feedback came, then they wait till somebody activates them. So that is, they need external control. So वो centralized भी हो सकता है, where you have these three systems called as a direct, where people will monitor it. So remember BMS, though I have not done this with you, it's in the final year. But BMS is a system, we call it as a building management system, or building automatic automation system. Okay, where all these sensors are kind of electrically looped and kept in one place where everybody observes, or at least this a team of people will observe and accordingly take the action. But there the manual so direct means that some person will then intervene to shut off the blinds, or but the idea is he will get an idea immediately. Okay, 44th floor, per though he's sitting in a basement, on the 44th floor the heat is high, and so I need to shut that. So yes, but he will get the information. while a reactive system where the sensors will apna hi kaam karenge, okay, but yet they will require a sensor, okay, the system will not work on its own. While in a decentralized intrinsic, the system will work on its own directly. And system based is again, it does all this processing. First the feedback comes, then the sensor will work, sensor will pass the message to multiple to this what do you call, processors, okay, who will then solve all these kind of, maybe there can be a fuzzy thing. When you talk about intelligence, वो थोड़ा problematic होता है, because वो कितना data लेगा, and today it's a data driven world, right? We have data on everything. We have data of say around 20 years of climate, okay, we have data on 20 years of the building usage pattern. So probably he will try, or it will try, sorry, the computer will try to figure out ye kya hai, wo mismatch. Maybe humans will not be able to come up with an answer so fast, which a system based processor will be able to do it for you, okay. But so basically what I'm trying to tell is, okay, you will require these other gadgets for the system to work. So that means it requires external control, and that's why the intrinsic control is there. But it happens centralized. आपको एक ही रूम में सब कुछ हो जाएगा, with a few touching of buttons it can happen, okay. While decentralized is something like direct, okay, but it can be active, where with the help of the wind it will start moving or something. It might not be needing these kind of thing, but it will not even kind of work like intrinsic. Intrinsic completely takes control. Decentralized in intrinsic will probably just move the system and kind of alleviate a little problem. It will not help you to completely kind of give you the or unless you will have to intervene. So this is about how the control and the different systems are there. And now we'll come to the different kinds of systems that are existing. Some of them some of them you will be hearing for the first time. You might have heard about it, but probably aapne kabhi uske, what is it exactly, you might not know, okay. So let's do this, okay. Second. Okay. Okay, so this is the first system. That's the passive facades, okay. So now we start with the actual typology of facades. There are some 6 to 7 facades that, and there are more, but they are kind of repeat kind of a thing. So what is a passive facade? Which you have done in first year, second year, third year, okay. Basically originates from a series of architectural passive design solutions, where you decide that, this being Delhi, I really don't need to open up my windows so much because it's very hot outside most of the time, okay. Versus in Canada, where you will say, I would love to have the sun pouring in, so I will have a large facade window, so that kind of a thing. But basically, so according to the climatic variation, you will actually put architectural features which will help you to adjust comfort levels within your zone, okay. It can be any type of building, and some of them are double skin facades which you have already done, okay. So I will not go into detail, but there are some details shown here which I'll just take you through, okay. Trome wall, we have discussed this in detail, and you have done case studies in second year. Buffer and opaque ventilated facades, which I just spoke, where a certain part of the building is purposely, they are also known as a spandrel system, and the transparent system. The transparent system is where which allows the light to come in, and spandrel do not allow the light to come in. And spandrel system are basically used to hide, abhi aapne curtain wall use kiya. So there may be some concrete kind of a thing below, behind, of course, supporting members, right, which you don't want to be seen. And so you would put something opaque there. So opaque and transparent is always a part of the facade, okay. And these are some of the I mean, these are few. I mean, solarium hai, and there are many others, okay, which can become a part of a facade system. Okay, and this is the example that I got from the net, and this is Morvian library, okay, and you can see they are using the passive facade. Now, let me tell you, passive facade has a very thin line. You cross the thin line, it can go into the intelligent facade, okay. So basically, if you work on your passive strategies, that's why they say it's you are intelligent, okay, because you are using the right kind of thing. So if I zoom this, you will know this. Oh, what did I do? This, yeah. So can you see this? Now what happens here is, you can see this is the window. This is the first layer of your facade, okay. And as I said, this is DSF, double skin facade. So this is my first facade, and where I place a normal window, of course insulated and all. And this is my openable louvers kind of a thing, okay, which can be worked and can be worked on actuators, it can be worked on sensors, which will automatically open. The reason they have to be worked automatically is because, as I said, this is not something where a small building, it's a big building. And when you are talking about a large building, some people might want it, some don't want it. So it basically, human interface generally is not so very active here. In such a scenario, you need this kind of activation system which will work. Now what happens here is, during the heating, and it's very simple, the one the stack effect wala effect is same, so I will not go into the detail. You know how the passive facade works. So this works. So during winter, obviously I don't want cold to come in, I'll shut this, okay. But these are also having partial transparency, so which will allow the sun to come in, and this space will become very heated up, which will then allow the heat to come in, and my space is automatically heated up. Versus exactly opposite reaction in the summer, when I don't want the heat to come in, okay, I want the heat to escape. In that scenario, I'll open this, okay. So there will be a ventilation happening, it allows the ventilation, it opens up this also, okay, and this is working on this thing, okay. So that's how the entire things function, and this is how it is, okay. And this is how the elevation looks. So these are the metal rings which allows them to clean, and these are the double skin facade. Okay. Any questions before I go on? Okay, fine. The next is active facade. Okay. Now, active are basically facades which basically takes help of technological systems without sophisticated electronic controls. Okay, कोई control नहीं करता है. They just basically technological, mechanical. I would use the word mechanical here instead of electrical. Okay. So, and I strongly suggest you guys, because this guy is amazing. His name is Ned Khan, Kahn, same as Louis Kahn. Okay. Just go on his site and visit. So this facade that you see on the slide is Children's Museum in Pittsburgh. Okay. And what he has done is basically use this some thousands of chota aluminium pieces. Okay. And I'll show you the detail of how they are fixed. Okay. It's really beautiful. So what happens is, when the wind comes, this whole facade kind of, you can see it's like broken up, and the patterns of the wind can be, actually you can see the wind. It's like he's making the wind visible, because as the wind moves, the light pattern, which, so you can see this, right? You can see this opening in the facade here. And I hope I have another pictures. Okay, so this is the detail, and I hope I have, no, I don't have it. I don't think I have another picture. But anyways, you can go on his site and see. So basically what he does here is, ये पीछे जो रहता है ना एक बड़ा सा, you can see here, yeah, it's the same thing here. You can see that this is a nice space frame kind of a stuff, okay, not a space frame, but a grid kind of a thing, okay, metal grid on which you will have this, and the detail goes like this. So this is the metallic frame that holds that. These are those aluminium chota pieces, okay. They've enlarged it, but they are quite tiny, and they have to be tiny, because then only I'll get the shape of the wind, and then only they become very light. If they are bigger, then obviously the self weight itself will not make the wind to move them. So basically क्या होता है, you can see this. So ये तुम्हारा, you can see this is a frame, okay, and of course there are holes in it, and so this bar into which this will be entering it, and then you screw it up. So that's how you will see the screw happening here, okay. But this is not hinged below, so this moves, okay. So this has a capacity to move aage piche, yeah, maybe even little bit here. This is again a kind of a pivoted. So it is not actually like the one which is getting inside this bar is not like a complete fit. So there is a little sound as well. Also there is a sideways movement, a very little bit, okay. So this is how the entire structure of this facade is done. And there are beautiful videos available, and not just one building. He has done many such buildings. The same kind of a technique he has used in Marina Bay, but there he has also used another very beautiful technique, which I'll show you aage jaake. So this is another building. This is, I think, ICT Media in Barcelona. where again it's an active building where things move, okay, but there is no electricity involved here. So the movement यहाँ पे किससे होता है? You might have heard about this material. It is known as ethylene tetrafluoroethylene. I have written down on a paper because I will definitely not remember this. It is ETFE. And basically it's air cushion. It fills up, and I'll show you the details. So यहाँ पे भी what they have done is the entire building is actually from below na. It's a steel structure first of all. And this is kind of a space which kind of holds these the facade systems together. This is definitely north side, okay, which is they've left open for the sun to allow to come in and the light to come in. And this is how the entire facade is kind of, you can see it. Is there? Do you see the second slide that I've changed? Yeah. So this is how the this is how the south and the west side of the building has been treated. Where these panels, okay, these are made up of ETFE material. ETFE, by the way, guys, what is ETFE? As I said, it's an amazing material that has been, it's amazingly costly, no doubt, but it is about 100 times lesser weight than glass. Okay? It is far more tougher. Third, it is far more better insulator than a glass. So in way and way, it helps a building to be lighter, to take more loads. Okay, it doesn't load onto the building's structural system, and at the same time, it gives amazing kind of, it's translucent, so it gives me amazing light. At the same time, it keeps the heat out, okay, and heat in, or whatever, cool in and cool out. So it works that way. So this is how you can see iska fitting kaisa hai, I'll show you. Okay, and this is how the entire building is. You can see this V kind of structure columns that is being taken down. I hope I have one of the photo where they have shown that the entire ground floor is been left for the public to, and it's very thin kind of a structure that goes down. And this is that space, I mean, the jali or the grid that takes care of the, and these are where the struts are there. And on the strut, with the help of, I guess, screws, I don't know exactly because the detail was written in German, since this is but I can't really, I mean, I don't know the fittings of it, but basically this is how the ETFE material is been fixed to the thing. This is the plan, and again you can see the plan, the way it is, this whole similar to what Renzo Piano has done, all the services on one side, and the entire core is like left open for the public to mingle. Even on the above floor, it works this way, okay. And the blue thing that you see is something this. And this green thing was the one that you saw in the previous picture, was where this kind of junction happened, okay, where at the junction you can have these triangular pieces of the ETFE material coming together and forming a joint. So this is an active. Now यहाँ पे कोई electricity use नहीं की गई है. But what happens is the ETF it shrinks and enlarges, and what they have done is kind of taken passive also, because if you see in the previous one, the depth of the building, I mean the grid has been so good, well maintained, that you can see actually people moving out here. So it becomes kind of a very interactive kind of a facade. People can come out, feel the sun, be there, go inside, that kind of a thing. So this was another example of active facade. So this is how the detail is, okay. So this is a steel, I think, concrete B hai. As I said, this is all unreadable. I would have loved to read it for me to understand exactly what it is, but these are some of the details at the junction where triangular pieces of ETFE material comes and joins to form that flower kind of a grid. Right. And what is also important is, I mean, this is a service part, not a construction part, but look at the construction and the services and the integration of it. So the floor is actually integrated with the services inside. So this is a steel kind of a thing, where you have the, you can see this struts here, okay, and with the kind of boardings on the top, and all your services are within the floor. And this meaning, if you have this here, that means it's an air displacement system. That means it is a very sustainable system that works. So this is how this building ICT, and it seems this was the building No, sorry, not this building. It was the other one in Berlin. Um, so yeah, so this is another very interesting and really classic kind of a thing. So what happens here is, and what all you can see is just one black facade, okay? ये सिर्फ आपको एक black facade दिखता है, and you can see this various, इसका video आप please go and see, Marina Bay Sands tipping wall, okay? The name, it's called as a tipping wall, again done by the artist Ned Khan, along with architect Moshe Shafdi, who designed Marina Bay Sands, Singapore. Now, if you see this, what happens is these are metallic tubes, और वो ट्यूब में से पानी आता है, and that means that these tubes are having very thin kind of a connectors, and behind this black facade is a complete grid of water lines, okay, which is able to pass water onto it, because they are not straight, you can see, okay, but they are pivoted. So the single pipe is able to move as per how the water inside moves, okay. And of course the wind is a powerful force which helps them to motivate. So agar wo wind hai, and if all of the water tips on the right hand side, if it is coming from the left, so accordingly the pipe will turn or twist or whatever. So it's really amazing. So what happens is, and also another wonderful thing is, this is placed on cooling towers. Now cooling towers ka function is to cool the heated water that comes from the condenser. So as it is, they want to cool the water that comes. So what they do is they pass it over this. So what we saw in fourth year in the AC lectures was those gigantic, not good looking cooling towers, right? With those jali and that thing happening. And but यहाँ पे ऐसा नहीं, it is converted into a kind of a landscape feature where the water is dropped from the top, okay, or through these pipes, and the wind is passing over it and it cools. It's collected at a channel below, filtered, and then brought back to the condenser. So that whole new way of thinking, I would say, and it's really amazing. Please go and have a look at this. Tipping wall, Marina Bay Sands, okay. So this is really amazing, but this is also active. कोई electricity नहीं है. So please be. So versus this, you have another kinetic. So the question can be, what is the difference between active and kinetic? Kinetic में they use electrical inputs, while in active it's purely mechanical, working on say wind or water or any natural element. So this is how it was. Okay. Coming to the next facade, and that is biomimicry. Sorry, I have not changed this. This is not passive. This should be biomimicry. My mistake. This is definitely an inspiration from plants and animals. So how a sunflower will track sun. We call it heliotropic, right? You will also come across a word called as a phototropic. Now, phototropic is not same as heliotropic. The difference is phototropic traces any light. It can be from a bulb or an LED, while heliotropic necessarily traces the sunlight, traces the heat of the sun, which is what sunflower does, okay? And so you have something very basic, okay? Something like problem solving. मुझे problem solve करना है, so I'll first focus on the problem and then accordingly I'll do very top-down approach kind of a thing. Okay, so this is exactly what a plant will do. ना मुझे ये problem है, I have to protect myself, and it will react. So that is a very kind of while on the second hand, on this kind, it is actually bottom-up approach where they have taken biomimicry, something like algae, and this is something was very difficult for me to understand. I'm not very good at biology, and this was all about bioreacting. So bioreactors are the kind of techniques used to create heat as well as electricity. Okay, I have yet to figure out what it is. Okay, probably Vikram, if you know, you can help me out here. But essentially, क्या होता है? So you can see this, and I have another slide which will show you. This is how the building is. This is BIQ house in Germany. So you can see this. Okay, these are the panels on the side, and these are the open view वाला normal तुम्हारा transparent windows. But अच्छा सा shading किया है because a lot of thing is coming out, and the reason of coming out is because they wanted to put these panels there. So the panel itself forms a very beautiful shade, and since this is in Germany, they do require heat to come in. So any which way, and the other heat that comes is from these kind of panels. So होता क्या है? What it does is these are known as a photobio reactors, okay, which is basically passive energy generation, I would say, biomass bolo aap usko, where heat is from biomass, definitely heat comes out, right? So heat becomes then the renewable energy resource. So This building, the 1/3 electricity, okay, comes from, no, I think even half of the electricity comes from these bioreactors. And they're actually cultivated in the basement. And the panel size is around 2 by zero point 0.7, okay, 2.5 by 0.7. So 2.5 you can see is the height of this. And obviously because they will need some of the क्या कहते हैं उसको supporting members का थोड़ा सा dimension जाएगा ऊपर से नीचे से, and so overall 3 में से minusing that you get just 2.5 meter height and about 0.7 meters of the width. Each panel is basically a set of two glasses, okay, and which is fitted with a kind of a frame around. It's completely packed, otherwise the water will come out, so we don't want that to happen. So you can see it on the side. This is how it is. So you have a frame on the side, okay, and then it is completely, I would say, hermetically sealed, okay, for these things to happen. And the algae gets its oxygen from the water, and somehow it creates energy, okay. This was designed by Arup. It seems it took them 3 years, and they did join up with some university to figure out how this algae will function. Unfortunately, I'm not the right person to discuss on this, but I found this really an amazing kind of an example to show you that this kind of things can happen. MoMA, that is Museum of Modern Art, which is very famous, has actually devised or using something called as a self-healing plaster. So say you build, so the plaster has kind of algae in it or bacteria in it, which which multiplies and kind of, so any cracks that develop in that wall, okay, automatically it gets filled up, and since the bacteria are growing, layers of it goes on. So it's a very beautiful way of thinking about new. So we can call this as a bioarchitecture or maybe bio walls. जो भी है. Of course, all this is linked to the BMS, that is building management system. Okay, coming to the kinetic facade, the one which I was talking about. Okay, 3 examples hai. There are many, but I have just taken 3. Okay, this is a heliotrace. Okay, this was just a kind of a prototype done. It was never used, but something like sunflower. It traces the sun path over time. But अभी तक इसका कोई use नहीं हुआ है. While this, the second one we all know, it's an Albar tower that utilizes about, I don't know, number of panels, maybe 1,000 plus. Okay, hexagonal panels. Okay, so this, if you see, this is an hexagonal panel shaped like a flower, which kind of resonates the Arabs mashrabia, that they have that partition wall. So it kind of resonates that. So it's very culturally placed and very famous kind of architecture. But opening of these, okay, and I have the how does this open, I have a detail later on to show you. Maybe iske baad hi aayega, I don't know. So this will allow the light to come in and open up, okay, or shut off. Also at the same time, the panels behind can be opened and allow the natural ventilation to happen. And all this is, as I said, it's kinetic, works on sensors, works on actuators. What are actuators? I'll tell you later. But these are the basically electronically monitored and motivated kind of panels which will move. So yes, they are active. So every active can become kinetic, but kinetic is not active. You understand square and rhombus wala equation, something like that. Because kinetic requires a little higher condition, and that means electricity, okay? Where active को electricity लगा के kinetic बना सकते हो, okay? So something like that. So this is how it is. And the last one is your very famous Jean Nouvel is the architect, and Arab World Institute in France. Okay, 30,000 photosensitive diaphragms are used, and the detail of that, and this is how the interior of that building is. Very beautiful, nice subdued light kind of fixes in. Again, he has used a very culturally resonating kind of geometrical patterns which Muslims are very famous for, Arabs are famous for. And this is how it is. Again, as I said, it's a activity electrical thing. So you can see these sensors placed here. Heat sensor sensing the amount of heat, detects the temperature, kind of allows passes the message on to the microprocessor, and these will start shutting off. And all of these will start shutting off. Okay, so it depends how much. And then of course they also record the internal, it's not just about external. So there are these sensors which are working both. One is only for outside, one is only for inside, but dono ka data jata hai BMS mein. And that's where the final output is then figured out, and how much to keep open and how much. So can you imagine, it just works like your brain, you know. When you get hurt, whether to cry or not, whether the tears should come or not. I'm just giving you an analogy for you to understand how fast these things can happen, you know. It's really fast. Okay, so that's the very important part for you guys to understand, that this actually works, and it works very beautifully. And what a feel inside. Look at the light that comes in, amazing light. Hmm? Yeah. So this kind of, even the feel of it is kind of an eye, you know, your eye contracts when there is too much of light. Okay, आप अपना आँख छोटा कर लेते हो, है ना? And even if you don't, the iris automatically contracts. Similar kind of a concept here. Very beautifully done. Mm. This is another facade, intelligent facades. Okay, अभी इसमें क्या फर्क है? Intelligent gives you options, which the kinetic didn't give you option. Okay, intelligent says that we are responsible for initial functions of perception, logic, action that have the ability to learn and respond in time. But at the same time, if a person needs to intervene at specific time for whatever reason, they are given that choice, okay, and that configuration. So it allows you that kind of mix match. GSW headquarters at Berlin is an example. This was the building that I was saying about. So this was actually done pretty long back. हम intelligent की बात अभी कर रहे हैं, but this was done, I guess, in somewhere around 89, or maybe even earlier. I'm not very sure. Okay, but this was one of the tallest building done after the wall came down. Okay, the Berlin Wall came down. सबसे बड़ा building जो बना था वो ये था. And it used all these amazing techniques. Again, who was the guy who was involved with this? The Arup consultants. Okay, you should really subscribe to their journals, which is available. So you should go on their site and actually subscribe. Some amazing projects and ideas, really innovative ideas you will come across, and they're really fun. I mean, you get just wow feeling. तो ये कैसे करता है? What are the two intelligent aspects used here? One is A, 70% of the year, the building is naturally ventilated by thermal flue inside the DSF. Again, यहाँ पे they are used to, remember I said, DSF has a very strong potential to go intelligent, where if I do not use automatic control wala machination, okay, if I minus that, it becomes passive. So again, if I have to upgrade passive, it can go into the intelligence. Okay, if I have to upgrade active, it can go to the kinetic. I hope you get the difference. 70% of the year, the building is naturally ventilated by a thermal flue inside the DSF, and which I already explained in the passive strategy, where we studied that Moravian library. And the other intelligent factor that is being used here is automatic control of the ventilation, or whether naturally or mechanically. Okay, so again, the options are given here because it's intelligent. It gives you options कि आपको जो करना है करो. And obviously, while manually overriding is possible through a wall-mounted zone controller. So every floor, every zone of the floor is given this zone controller. So in case I am sitting on 44th of this building, and if I want to control something which is, say, nearby me, I have the capacity to do that, provided I know the working of the zone controller. Okay? So this is the advantage of intelligent building versus kinetic. Kinetic is completely processor based, do not allow any human interference. सब कुछ BMS करता है, and that's where sometimes people feel कि what if I want more light? So that is the thing. Okay, so along with intelligent facade, it also because it's as it says here, it reads, okay, it initial perception bolo, logic bolo, action bolo, and as I say, data driven world is what we are living in today. They have the capacity to actually make graphs. Okay, they can actually read that, and they can predict that this, so all that thing can happen, kind of AI, intelligence, where they can actually understand ki how can automatic and occupant control can be matched to give ultimate comfort. Sounds little very high tech, but believe me guys, it is done through processors, and BMS system is really an amazing automatic system where it does things at a very fraction of second. So we call it as a nerve center, okay, where all kind of controls happen. So this is how your this thing, and obviously all of this is then linked to the HVAC system. So the moment I say 70% naturally ventilated, automatically HVAC goes off. Nobody has to manually do it, so it is possible. But at the same time, if somebody says natural ventilation is not enough, and in my zone I do require a certain temperature, then I have the possibility of shutting the windows, making it a closed zone, and starting off the HVAC. Again, HVAC is then zoned to see to it that it goes only to that zone. So that is the power of BMS. So I hope this is clear. Any questions, guys? And
No.
they all kind of sorry, I'll just finish this. And they use all kind of techniques. They will use smart materials, they will use actuators, they will use kinetic factors, सब use करते हैं. ठीक है? Okay, so I'll go ahead. Another kind of facade that is interactive or media facade. Okay. Another thing that I would like to say, a kinetic जहाँ पे आपके sensor sense करता है, active does not do that. By the way, so active वाला जो facade आपने देखा, that movable छोटे छोटे aluminium वाला, remember that wind वाला, they not necessarily control or feel the thermal comfort. They are just active. They are entertainment के लिए है. Okay. They might not be, but yes, what they do is they can kind of create better shadows inside, create patterns inside. It can be quite beautiful and all that, while kinetic is actually dealing with the climate and giving you the comfort. Okay. Something similar is what interactive or media facade. They don't need necessarily do anything with the thermal comforts, or try to adopt to the climate and all that, because they are basically responding to movements that can be human as well. Okay, so you can actually see these guys pushing their hands up, आगे पीछे घूमते हैं, and you can see these kind of facades being generally introduced in lounges, or on a facade where they just want people to interact with the public space that they may have planned at the ground floor level of the building. So these are the kind of those surfaces. They need not necessarily be the kind of interface between indoor and outdoor, but they are just interface, okay, and doing nothing for energy level, and could be just a fun factor. But they can convert into the other if you apply sensor and all that, the one which we talked about, it could be converted into that. Fine. So remember this, the transformation can happen, but essentially when we say interactive or media facade, it is purely for media. It is purely for what do you say, sound and people movement, and then how the changes happen. You've seen those fountains, right? Fountains are programmed, and in some fountains they are programmed according to the movement of the people. So same thing, something here. Yeah, so this was at a Hypersurface National Museum of Energy, Spain, where they are utilizing these kind of facades to show them that this could be one of the ways where sensors and microprocessors, uh, and in combination with human input, energy could be produced and could be put to use, but it's not yet been used anywhere else. I think we are coming to the end of it. Movable facades. Okay, अभी आप बोलोगे active भी है, kinetic भी है, अब movable क्या है? Okay, it's like I would say a big brother of kinetic. Okay, have a ability to rapidly adjust to environment. Okay, now see this wall. Okay, and I'll show you the other picture of it. You can see this. Now from here it can go here. Okay, which was also possible in the kinetic. Okay, so actually even I have a I don't know. but I just saw this amazing picture, and these are the solar panels. Okay, so what happens is, this picture you can see it's all flat. Also, the movement of the solar panel happens. Okay, so this entire thing moves like this. So that is one thing. And second is, even on that moving panel, the solar panels, which are these, okay, they start moving. So the facade is moving. Okay, so this is moving on a slider that is here. Plus, at the same time, the panels also moves. Okay, so as per the, so they trace the sun, and accordingly the panel will open out, and you can see some of them are under shade. So the moment they realize that the angle is not right for me, they will change the angle accordingly, and see to it that they get maximum sunlight. So that is, so basically, therefore, they control the indoor kind of an environment. Okay, user comfort ज़्यादा उनका focus रहता है, and that is how they are different from the kinetic. Kinetic focuses mainly on the outside, while movable facade, it seems, and that's what the, and I'll post that. If I get that PDF thing, I'll put it here. Although I got these information from various Google sites, so, and it's all Google pictures, huh, guys, completely. So this was EWE Arena. The building is quite nice. Okay, and you can see that and you can actually imagine that as per the sun, the elevation of the building will keep on changing, because each panel will want to get maximum sun, and that's how they kind of create PV panels. They create about 27 some megawatt per year. You know, I mean, it's amazing, just from the facade that comes. Okay, this building is very famous. Okay, popularly seen on any moving facade. These are the rollers on which this panel slide, and they are Kiefer Technique showroom. So responsive facade performs function and similar performance characteristics to an intelligent facade, including real-time perception, smart material, kinetic components, building automation, and user-oriented operation. But there is a but. That's why this is known as responsive and not intelligent. Okay, but also is an interactive facade, as it is capable of learning to self-adjust by educating the building and occupants progressively. So it does one extra work of educating the building as well as the, so probably it reads and feeds back into the system, where again the system changes and then comes back and it changes again. So that way it does both indoor as well as outdoor reading, and comes to a maximum kind of a balance, where accordingly it will adjust as per the sun, as per the wind, daylight. Of course, it is programmed and all that. So that's how. So responsive, basically, it is defined how the facade is able to interact with natural or maybe man-made, okay, artificial systems within the people. Okay, so that's why, and so typical solutions are there. As I said here, same thing. Actuators hota hai, kinetic components में sensors आते हैं, controlling devices like processors will be there. Everything is there. Okay, but the difference is user interaction and ability of the system to feed back to the system, telling them of the new conditions that they experienced, and so that's the added part to it. So basically it kind of responds, it just doesn't just sits there. Okay, so when like I say na, respond. Okay, जब आपको lecture दिया जाता है तो response आता है तो अच्छा लगता है. So similarly, if a system is working but it responds back to the system and says, okay, this was a new experience, and probably log into it, that kind of back and forth is what responsive facade means. And I guess this is the last, and that is this is the smart facade. Okay,
I have a question.
Smart material.
About,
Hello.
I have a question about the previous one.
Yes, Ria, bolo.
So when you say that the facade is capable of self-adjusting, like are there people who are actually reading the data of how the facade
Yes.
performs
Yeah.
and then changing it? Or okay.
That also, and I will show you a slide aage jaake, where there are people who are sitting and doing this simulation to understand how each system is working. So yes, there are simulations prepared, and this is actually feeding to even people knowledge, no? Because we might not be aware of when I'm talking about micro AI, I mean, sorry, not micro, but I'm talking about artificial intelligence, where imagine you trying to sit and analyze 20 years data, correlating with human comfort, तुझे कितना time लगेगा? Compared to this being done by a computer, okay? It will happen in matter of seconds. So when that kind of readings are possible, okay, the kind of patterns that evolve, okay, it will be a good study for us also to see how then we can do the simulation and which system can go where. And you can, I mean, from all the systems that I have just said, there are actually very thin line, very difficult to actually say कि kinetic, intelligent, responsive में क्या फर्क है ना? If there are very thin lines there, and it can very well go here and there. So it's quite okay for this guy to be called as intelligence, because yeah, it is doing an intelligent work. So the definitions are very kind of, I think they still need to be, people are still working on it. They are not yet very, I mean, hardly one building is using this building. Okay, nobody else is using this kind of a system. Maybe there are some other kinds of responsive system that have been used. I was able to get only this when I typed in responsive facade, this came in. So that's how you will see this. Did I answer your question?
Yeah,
Kind
yeah,
of,
yeah.
kind
Yeah.
of. Yeah.
I was just thinking, does it actually adjust its settings itself, or do people do it? But like, huh.
No, they do it themselves. That's the intelligence part of it, na? So BMS does it themselves. So BMS क्या होता है? So you remember in the fire safety in the sixth semester, we said that you are coming down, and we say na that the actually the ideal practices, the fire escape should open out. Okay. Now when I say that, that means that there is a door which is there in the fire escape staircase, which is actually leading you out and not coming to the lobby. That is how the ideal practice is. But then what we think is, अरे बाबा सेफ्टी का बात कर रहे हैं तो फायर तो once in a blue moon will happen, but safety from the burglar, safety from the outsiders, okay, and with these terrorist attacks, we would want to make as much strong kind of a fortress kind of a wall against these kind of intruders, right? So then the question is, who will control that door? So BMS have been known to control these, okay, because the locks have been computerized to match with that. So that kind of stuff can happen, you know. And you have seen this in the movies, that automatic lock khulta hai. What's that? It's nothing magic there. There are technologies in place that works in that. But you require special consultants for them, because we are not engineers. And if you ask me how the actually it works and what are the electrical connections, I will probably do the drawing, but the working of it, probably I need an electrical guy, or an intelligent IT guy. Okay. So this was about responsive facades. This is smart facade. Smart facade is all about using smart material. Okay. Smart material में भी कैसा होता है कि so there are various smart materials. So one very in trend right now is bimetallic, thermo bimetal. Okay. So you can see this. This is a Bloom project. Okay. This is it's basically a kind of a landscape kind of a thing, where it kind of creates a beautiful shade, and people can sit there. So it's basically it's not yet. I mean, I did not get any case study pertaining to this kind of a smart facade. Somehow I tried, but nahi mila mujhe. And so basically they do a lot of work. Okay. uh, they sense, okay, and since they are smart, they don't wait for others. As I said, smart material is that intrinsic kind of a control. They take instant decisions, and they start working on their own without any electrical or mechanical motivation. Okay. So that is where smart facade will be intrinsic control. The rest of the thing that we talked about was all external control. Okay. So this is the difference between smart facade and the rest that we talked about. And it's immediately, it's very like short term response hota hai uska, highly responsive. Okay. It can be, what do you say, intrinsic control hota hai, and there are lots of materials like phase change material hota hai, building integrated photovoltaic hota hai. So all these are, so they are known as BIVP, building integrated VP, which I have another example, Korean building, that is a headquarter of Korea commerce. So that uses BIVP extensively. So this is how the smart material works. What is smart material? It's a bimetal self-ventilating skin. So what happens is, and I have the, I think, the diagram to show how it works. So bimetal are laminated metal with various thermal coefficients, and they change their shape. So basically, kaise hota, if I draw it out for you, uh, pen is this, and so if it is like this, so if this is one layer of metal, this is one metal, suppose, okay, and then you have another metal, and they are fused together, okay. Now one will have a higher kya kehte hain, expansion, and the other one will have a lower expansion point. That means when the and but they are very sensitive, okay. The metal is not used something as very heavy jiska expansion point is like very high, then they will have to wait till the end of the day for it to become hot, and by that time the time is gone. So it has to be very sensitive. It's like using refrigerant for AC system. It has to be quick. Hmm. So same thing will be here. So these are sensitive materials that are used. Okay, they are thinner in section so that the faster the bending can be achieved. Now the principle works like this. Say this top guy gets heated up faster, and it will expand होगा तो it will turn like this, है ना, उसको ज़्यादा curvature चाहिए, so it will turn like this, ठीक है. Now when it turns like this, maybe the side वाला guy will not move or move, but basically it then kind of creates a space between inside, and that space creation is your job. How do you then shape your bimetal that will give you different patterns when they shrink and they expand, and how they fill up? So that is how the again all this thing is simulated, and I have a file that will show you a slide that will show you that how this can be done. Okay, so this is how the intelligent facade of automated wood louvers. So here you can see, sorry, this is not smart material. I don't know why this slide came here, my mistake. Okay, but this is intelligent facade where automated wood louvers with building integrated PV form. So you can see the louvers में उन्होंने PV का वो डाला है. But again, these are then connected to the electrical input. The electricity is then stored and utilized, and how to open, when to open, how much to open is again everything regulated, but with a manual control. So at the same time, if a guy wants to open up more, he has a right to do that, and he has a means to do that. Okay? So this is how it is. I'll show you another example of this. So now here it's very clearly seen. Hai na? Imagine this chap expands and this don't, okay, then there will be a gap in between, okay, through which a light and ventilation can happen. Imagine when everything of them shrink and expand, a beautiful pattern can be formed. Okay, so I think University of Southern California is doing a lot of research on this, okay, on a thermo bimetal. That's what I could get from the TED talk that I saw on this. Various bimetal industry, the metals that are being used in various ways. Really amazing kind of a technique where through simple mechanical property of I would not use the word mechanical, but the basic inherent property of the material is fused and then used to get light, air, ventilation, everything inside. Okay, so it's a beautiful way of detailing it out. Okay, and this is how the experiments are going on. So you can see this, see the shape that they have arrived. Now imagine when this guy expands, kitna expand hoga versus this guy, okay, or this guy, and then what happens to the space in between. Okay, and then how is this junction actually being done, because I am also looking at it to be not only smart but also kinetic. So what if I want to move the panel? So the whole thing is made very kinetic, and so you can see the detail. So this is how the this thing can work. So you can see that they can work, they can bend more, they can move a little bit up and down, and that's how you can break the way the sun comes in from this window. Okay, and this is how the building is made to look at. Okay, and then this works like a normal double layer skin also. So it's a multiple use of systems that they've used DSF, they've used smart material, they've used the stack effect to kind of get the best kind of a result within. And I think that is how it should be. If you know the system, use as many as you can. Okay, now see, this is the detail. So imagine this is one frame of the window that you are using your smart metal. Okay, and different patterns can emerge out of it. when they blow up, it becomes kind of this. When there is a lesser expansion, they become like this, or when they turn like this. So and this is how the fixture is. So this is a frame, and you can see there's a hole in it, okay, where you can finally, when this goes inside, and you can do it. So here is the final fixture where you can see that this side mein wo jata hai, and from here it is screwed. But then this is the external bar. Then this enters, and then this is pivotable, and that sorry, this is pivot on which this thing can be moved up and down. So that's why you get these movements. I cannot enlarge this. Yeah, can you see this? Yeah, you can see this goes inside, and this is able to move. And on base, and you can see this two thing which is here. Okay, so they are able to move like this. Okay, you got it now? What I'm saying, guys? You can see this arrow here. है ना? So this is where this pivot happens. ये ऐसे होता है. See, now this is moving टेढ़ा, और फिर ऊपर जाता है वो. That's how it is, and this goes at this angle. Yeah. This was the simulation you asked me about, right? So these are the systems, and then people will sit and do these. Okay, from this kind of a facade. So they have just named it randomly, A2, B2, C2, D2, ऐसे कुछ random नाम दिया है. And they're just working out that with different systems, different kind of data is received, which is stored, patterns are made, and then simulated. And when you get these kind of color graphs, which tells you that from all of these, I think this is the best. I mean, if I'm talking from Indian point of view, right, where I get maximum cooling, which is what I need. So then I'll go for C2. Okay, so this is what I will go for. And you can see from it that it puts the sun out. So this is how system generates data, which feeds into the system back again. And system here is, I'm talking about facade system, okay, while that is a management system. So the system facade system generates data, feeds into your management system, and that's where the what do you call, the data is. Then again, as I said, it's a data driven world. You set up data, and then you can use those in future and predict and kind of come up with new systems, new details, probably new materials, and hopefully some more smarter means of doing it. Okay, so this is how. So I hope I answered your question when I say, okay, yes, the data goes back to the system as well. Otherwise, how will we help? How will it help humans? This is this is the I think there is a lag. Can you see, guys? Yeah, this is, I think this is the last maybe last few slides are remaining now, 10 more. But quickly I'll go through. This is the famous star Albar. Okay, and this is how it looks. Okay, this is when the everything is shut and tight. It's like 3 o'clock at night, maybe, or maybe 3 o'clock in the doper ka, and we don't want that bright sunlight to come in, and everything is shut. You can see nothing opens up. It doesn't look like a flower. Okay, so this is how it looks in the daytime. Okay, this solution is software driven, BMS. Okay, completely kinetic. It moves. So this is how it is, and this is how the plan is. Okay, these are the two the whole towers. Okay, that was seen in the previous picture, and this is how the whole thing opens up. When it registers that the inside needs this kind of a light, and the things will move. How will it move? It will move through sensors as well as actuators. Okay, so Mashrabia, as I told, it was how this entire thing was imagined. So the each pattern is actually a hexagon, 6 point, and it's very effective in protecting it from the harsh Abu Dhabi sun. Okay, so intensely relentless, I would say, kind of a solar gain that happens here. This is how was when it is closed. This is how when it tries to expand, and this is how where the 3D kind of a thing will happen. So you can see how, and you can see the light pattern that is formed here. You can see this kind of a patterns that will be formed inside when it partially opens up. Okay, and in the previous picture you saw that it was completely opened up. You can see that it was, I have gone back and it's not changing. There is a lag. God, quite a big lag. Yeah, so here you can see that it was completely open. While in the previous one, sorry, the next one, you saw that it doesn't really have that kind of openable, and only certain parts are opening to give me a very nice kind of a light within. Say it's afternoon time and I want only basic light to come in, then I would go for it. Okay? So this was exactly that. And this is how the final working of that entire thing is. Let you see the, let me wait for you guys to see the slide, then I'll speak. Yeah, so this is how it is. Huh? Now jara idhar dhyan do, huh? Just pay attention. Okay, so these are the frames. Okay, this is the panels. Okay, the transparent panels. Okay, uh, this is what is allowing the sunlight to come in, and basically even the wind to come in. Okay, so now what happens is, you can see this is the frames that are done, and यहाँ पे जो है ना, ये वाले ये तुम्हारे actuators है. Now what is an actuator? Anyone has an idea about what is an actuator? जो नाम है वो काम है, वो actually काम करता है तुम्हारे लिए everyday life में. Okay, for example, if I have to give you an example, the actuator works in your self closing door. बैंक में जाते हो, you go to the mall, you approach a door and it opens. Okay, that's an actuator. Basically an electrical energy input that allows something to move is known as actually working actuator. That is actuator. Another thing is, you can do this pneumatically or using force as well. Okay, uh, I don't have any example for that, but anyway, so there are different kinds of actuators. I'll not go into those kind of details, but यहाँ पे क्या होता है, let me tell you. Okay, so what happens here is 50% of the solar gain is reduced. Okay, also equal amount, that is 50% of daylight requirement is reduced. यानी कि sorry, the daylight load is reduced. Okay, because of these kind of tinted glass that they have used, and this kind of material that they have kind of looked up. Only those facade are kept open, like north side, okay, and east. The rest, south and west, is completely covered up with these kind of mashrabia. And this is how exactly it is, the functioning of it. uh, I mean, you can take a, I mean, you, of course, you can go through it aram se, but I'll just tell you what it is. Okay. So the actuator is this one that I told you. This is the one that I told you in the previous picture. ये है आपका electrical insert, which gives the current. Okay, for it to move. Okay, so the strut sleeves are there, and these are then basically it moves. So you can see here in the side panels. Okay, quite origami kind of a stuff. Where the whole thing starts folding up, because the joints are made where you can actually allow that strut to fold up. Okay, and that happens because electrical क्या कहते हैं, jolt or whatever is given to that for it to work. So this is how, if you want me to read this out, I can actually work for you. So this is the second one, is your strut sleeve. So this strut, you know, strut is a member which helps you to kind of works in your support system, right? So the support system doubles up as a service kind of a system, which allows the wire to come in and allows the electrical input to come in. Okay, so actuator plus power and control cable connection back to the tar matlab tumhara BMS. Strut sleeves penetrates the curtain wall and connects to the main structure. So this is your main tumhara jo structure. I mean, sorry, this is your structure of the mashrabia, while this is where my main structure ka wall will be. So this is that second is that. Okay. Third is supporting cantilever struts, hooks on the sleeves. The third is this. Okay, where actually your second and third same hi dikhta hai. I'm not able to make out from here. But basically, I mean, if you go through this, you will understand that how this entire thing works. The whole thing slides up and you can open up like this. You can see in this picture, and that's how it works. This is how it looks when it is opened up. Okay, and it's the fun part is not everything will open up at same time, because if the sun is there and only that is registered, then that will open up. So again, you will see different patterns on the facade. So it's quite interesting to note different patterns that fall on the facade at different times of the day. Yeah, again, another picture, just a picture. Yeah, okay. This is again intelligent facade, double skin, but again in quite a detail. Basically the same what I explained you for the library, okay? But यहाँ पे they are allowing the signals to go back and forth to the BMS system instead of passive where there was no electrical, there was no mechanical, okay? It was working on its own. You actually have to go and manually shut the lures and it will shut and the things are working. So this is without people getting it, and if you want to add your 2 bits to it, you are allowed to do that. So that is how the entire thing is, okay? So here you have single glaze tempered outer. So this is your one, okay? Single glaze tempered outer. What is it? Life? I don't know. Okay. Mechanical ventilation damper. So again, as I say, this is intelligent. So you will have all these kind of mechanical, electrical kind of things happening here. And you know, damper is a instrument which allows you to divert the air here and there. It also allows you for fire restriction, means smoke restriction. Automated window blinds, that is 3, यानी कि ये है आपका automated window blinds. Tempered glass floor is this, okay? Please go through it, okay? You have the file, you have the detail. Vikram, would you like to add something to this? I mean, this is the last slide. No, there is one more slide. I think 35, 37 hai.
No, Minal, I think this is uh, actually when we discussed this is fine because this gives an overview of the facades and all. But I think we'll need another session for the for high-rise buildings with the wind stresses and all, how they perform under wind stresses. So some examples like those will be presented, but we can take it next time. It's okay.
Yeah, fine. Yeah, okay.
Okay.
Yeah. Okay. And then this is the last slide where, as I told you, this was building in Korea, some headquarters for commerce, where these are the solar panels, and which allows the transparency to happen. But now look at this. Look at the last picture, okay, where complete, the heat is avoided, and you can get light, but not the heat. And but at the same time, solar panel receives complete heat rays. So that's how maximum energy is created. Minimum heat is entering the light. So this angle, I think they've maintained some 15 degrees angle to happen that, and this is how the entire system is worked, where you get very beautiful sunlight inside but not the heat. Yeah, so these are some of the examples of how smartly the facades can be used, okay? And thank you. Any questions?
No, no.
No questions?
Vikram.
Hello? No questions?
No, it was quite straightforward. So
Okay.
Yeah.
Fair enough. So, anything which is related to the means, of course, we have finished the thing, but the next exercise that we are beginning from tomorrow, related to your previous semester's work. If there are any facades or any envelope systems that you want to look at, whether if you want to look at any of these kinetic architecture or not, we can take that up also. So, but then the exercise is going to diverge. So maybe you could also relook at the high-rise exercises itself and look at whether you have covered these aspects in the facades or the analysis of the facades that you have taken up. Yeah. So that is one. Yeah. So next time I think we will. We'll look at least we'll spend some time 15-20 minutes on getting the simulations about how the facade systems themselves are tested or what in terms of wind stresses as well as earthquake, this how the facade systems are required to be tested, and what is the process that is followed. So that is another thing which is pending from our side. Um, yeah, then there is one topic which is remaining about the piles we have covered, but we have not covered diaphragm systems, right? And
Yeah.
also we have not covered the construction of the piling system itself, correct?
Yeah. We just mentioned the piles, I guess. I mean, I don't know what
Yeah,
happened in the
we have
first
we
week.
have done the introduction of piles and all. We have done the application of it, but the detailing of piles was pending. Students, anyone? Hello, somebody respond, please.
Yeah, I think construction and all we've done. I mean, sorry, construction. We've done all the understanding of what how the pile works and everything, but how it's erected and all, I think it's left. So
Mm. No, that's what's up. But we need to have. You need to at least we need to know that you're listening, right?
yeah, yeah.
So anyway, so those are the two topics which are pending. So the next 2 weeks we should be able to cover that. And there was supposed to be a mid-semester test, but we had scheduled it on immediately after this exercise. So just to get the grades in place, right?
Yeah.
So today we are on 23rd.
Yeah.
30th we'll cover that. So maybe
Maybe first week of September,
6th को.
maybe.
Okay. ठीक है. 6th we'll have a quick test on the topics which have been covered so far. Does that work?
Okay. All right. Yeah.
Yeah. Okay. Thanks. Bye.
Bye. Thank you.
Thank
Thank
you.
you.
Thank you.